limits at infinity and infinite limits. So let's do that now. We have a graph here, and we're asked to find the limit as x approaches 1. So we can look here at 1, and as we get closer and closer to 1, well, it looks like we have a vertical asymptote here. So if we're going up in one direction, down in another direction, in opposite directions, our limit at 1 does not exist. Now, if we look at our limit at 2, we actually do have a limit here, right? So if we come to 2, it looks like maybe our limit's about -2. I'm going to put it right there. We come from the left, we come from the right, we have the same thing. So our limit there is about -2. But as we go to 3, and actually this is misdrawn, but let's instead put it 4. So it's actually accurate. As we come to limit as x approaches 4, we come from the left, we come to the right. We do actually have a limit there, it's 1. We don't actually have a value at x equals 4, but we do have a limit. Well, let's look now at our limits as we approach infinity. As we're going towards infinity forever and ever and ever and ever, it looks like we're getting closer and closer and closer to 2, but we never actually touch 2. Then likewise, as we look at our limits as we go to negative infinity forever and ever and ever and ever, we get closer and closer and closer to 2, but we never actually touch 2. So those are our limits. So really, when we ask about limits at infinity, we're just asking, where is the horizontal asymptote? And here we can see our horizontal asymptote is at x equals 2. Let's go through another example. So we have a graph here. We actually now have 2 horizontal asymptotes. As we go towards infinity forever and ever and ever with our x values, we're getting closer and closer to 2. But as we go towards negative infinity forever and ever and ever, we're actually getting closer and closer to -2. So what about calculating these limits at infinity if we don't have a graph involved? Well, what we're asking ourselves to do is just find those horizontal asymptotes. And to find our horizontal asymptote, we basically are just going to look at the degree of our polynomials and divide. So here we have 2x plus 5 over 3x squared minus 12. So if I wanted to simplify this, basically the x here is going to cancel out. When we're talking about infinity, everything like 5, -12, they're just not going to matter. They're so small in regards to infinity that they aren't going to make a difference. So now we're going to have 2 over 3x. And if we plug in infinity for x, we're going to have a really small number over a really big number. And if you actually put that in a calculator, I will show you here. I'm going to put this in my calculator. If I put a really small number, like 0.000, and I'll just leave it like that, 1, divided by a really, really big number, I get this 1 point e to the -7, which just basically becomes close to 0. So our limit, if we have a smaller degree over a larger degree as we go towards infinity, is going to be 0. All right, let's look here. We have 2x squared plus 5 over 3x squared minus 12, same denominator. Well, in this case, we're going to, again, the 5 and the -12 are negligible. But now we're going to look here. Well, x squared over x squared, if I put infinity in for x, I'm going to get infinity squared over infinity squared. Those are actually just going to cancel out. And then I'm just left with my coefficients. So my limit as x approaches infinity here is 2/3 when I have the same coefficient or the same degree of my polynomials. Let's look at our last one here. Limit as x goes to infinity, we have 2x cubed plus 5 over 3x squared minus 12. Again, 5 and 12 are not going to make any difference to what we're doing here. But we can take this, we're going to have this x squared is going to cancel out, and we're just going to end up with x there. Well, now we've got 2 times infinity over 3. That's not going to make any difference. This is all just going to become infinity. So we don't actually have a numerical limit there. So let's go through a few more. Here we have the limit as x goes to infinity of x to the 4th minus 6x squared over 2x to the 4th minus 5. Again, this -5, these cancel out, nothing matters here. X to the 4th over x to the 4th, those are going to cancel out. Our limit here is just going to be 1/2. What about negative infinity here? We haven't talked about that yet. Well, 5 and -3, those don't matter. Now we've got 2x over x squared. I'm going to cancel out that x. So now I have a 2 over negative infinity. So our limit here, a small number over a very large number still, is just going to be 0. Okay, sorry about that. So now let's look at our third example here. We have 5x squared plus 6 over x minus 6. Again, 6's don't matter. This x is going to cancel out. I'm going towards negative infinity, so I have 5 times negative infinity. My answer here is just going to be negative infinity. Here, 2 doesn't matter. X doesn't really matter either. We're just trying to look at our biggest, our first coefficient there, so x squared doesn't really matter. So now we have x is going to cancel out here. We have an x squared. So we're going to negative infinity, and negative infinity squared, negative times a negative, is just a positive. So we actually have positive infinity here. All right, let's look down here. Number 5, we have the limit as we go towards infinity of 12x minus 2 over the square root of 9x squared plus 4x minus 1. Well, if we take the square root of this, we end up with plus or minus 3x, right? Well, now we have 12x over 3x. I'm going to just write that down. 12x over plus or minus 3x. I need my x's there. So these cancel out. And so now I have 12 over 3. So I'm going to have positive 4 and negative 4. That's actually where my asymptotes are going to be, at x equals 4 and negative 4. So what about when we're getting towards infinity? Well, as we're going towards infinity here, we would have positive infinity over this is going to be positive, right? Because infinity squared would be positive. So this is going to be towards positive 4, right? But if we go over here, we would have 12. This actually simplifies to the same exact thing, right? These are the exact same. But if we plug in negative infinity here, because this is positive, that's a positive infinity. I should put a little plus sign there. This is negative infinity, so we have a negative over a positive, so we end up with negative, not negative infinity, but negative 4 towards our other asymptote. All right, what about finding these limits analytically? And now some of you have actually asked about this, and this is a great question. What if we want to find a limit like as x approaches 4 from the left, or as x approaches 4 from the right? Well, we have the exact same equations here, so let's examine this. If we just put in 4, that's not really going to give us any valuable information. So let's choose something that's just to the left of 4 here. So I'm going to choose like x when it equals 3.9, right? And I'm just to make this simpler for myself, I'm going to actually put this into my calculator so that I can just calculate this easily. Minus 2x plus 12 divided by x squared minus 6x plus 8. And since I'm using this for 2 problems, this will make life much easier for me. So as I put in, if I put in 3.9 and I trace 3.9, I get 138, right? But over here, if I trace, instead of 3.9, I'm now going to trace 4.01. I guess it doesn't really matter, right? 4.01. I get negative 1,402. Well, what does that mean? If I look at this graph, I can kind of see what's going on here. If I trace 3.9, I got 138. I get a number that's all the way up here. I'm going towards positive infinity. But if I traced, and it got all smudged, 4.01, I got negative 1402. That's all the way down here. I'm going towards negative infinity, right? Let's try another one. Here, if we have x squared minus 2x plus 5 over 2x minus 2 of 1 from the left, I can try out at 0.9. And same equation here. I want to go 1 from the right. I can try at 1.1, right? And you don't actually need to use your calculator to graph these. I mean, you could just plug this in if you really wanted to, but that's a little time consuming, and for the sake of my mental health and yours, I'm going to use the calculator. Minus 2x plus 5 divided by 2x minus 2. Make sure you're using your parentheses so that things graph correctly. Ooh, we've got a beautiful graph here. And again, I'm going to trace 0.9. I've got negative 20.05. So it looks like I'm going towards negative infinity. And if I trace 1.1, I get 20.05. It looks like I'm going towards positive infinity. All right, there's one last thing I want to talk about quickly, and I have already touched on it a little bit, so it should be mostly review. But basically, I want to talk about how to find an asymptote. So for horizontal asymptotes, you're just going to compare your polynomial degrees. Here, 4x squared minus 5x over x squared minus 2x plus 1. Compare these, x squared over x squared cancel out. Your horizontal asymptote would be at x equals 4. Here, x squared minus 9 over x plus 10. Horizontal asymptote, you have a larger number over a smaller number, so you don't have, there is no horizontal asymptote, right? Here you've got a smaller number over a larger number, so your horizontal asymptote is equal to 0. And that lines up with what we talked about earlier, right? Now, for our vertical asymptotes, all you're going to do is set your denominator equal to 0. So for this first one here, x plus 5 equals 0, so x equals negative 5. You have a vertical asymptote at x equals negative 5. Here, this actually needs to be factored. You've got x, looks like it's going to be minus 2 minus 1. So you're going to have a vertical asymptote at x equals 2 and x equals 1. And the last one, slant asymptote, this might be the one that you maybe have forgotten. All you have to do is divide the numerator by the denominator. I'm going to actually use long division for this, which I don't do very often, but it is kind of fun to do. So x goes into x squared, x times, right? X times x is x squared, x times 5 is 5x. We have to subtract. So now we get negative 11x plus 7, and this goes a negative 11. So negative 11x minus 55, subtract, so now these become positive. This doesn't actually matter here, so that's 0. But this is the equation of the line that we need. So we have a slant asymptote at, I guess, f of x, or y equals x minus 11. Because remember, your slant asymptote isn't just going to be an x equals or a y equals. And actually, I should say up here, vertical asymptote here, my horizontal asymptotes should be y's. What was I thinking? Y's. But here, our slant asymptote, back to this, remember, is just going to be like if you had a graph like this, and this is hideous, but you're going to have an equation of a line there. All right, so that's basically it with finding limits at infinity. You've already had a lot of experience with this, so hopefully you'll do very well. Look forward to seeing you in class. Bye.